In this lesson, we're going to go through lower block science for primary 3 and 4, the module of energy. We're going to be focusing on the lesson of heat. It's a big topic, so it's quite a lot of content to go through. Now, first of all, what is heat? All right, so what is heat? Heat is a form of energy that makes us feel warm. All right, so if you are standing here and there's sun and you say, hey, I feel really hot. I feel very, very hot because of the sun. Now, what's happening is that the sun is giving you a lot of, let's draw it red here. The sun is giving you some heat energy, which is making you feel warm. All right, so that's basically what heat is. Okay, so what happens when an object's temperature decreases? All right, why does it decrease? Because the object lost heat. Okay, so heat can actually move. Heat can travel. So let's say I have a box over here, or even better, I have a person over here, and this person is feeling hot. And now I put him in an aircon room and he is feeling cold. Okay, so now he's feeling cold. So what happened from here to here? It's that this person has lost heat, and that's why from feeling hot, this person is now feeling cold. Okay, so that's losing heat. An object's temperature increases because, why does an object's temperature increase? So because the object gained heat. Okay, so let's look at this hand. The heat will always travel from the hotter to the cooler. All right, so between ice, this is ice, and this is the hand, which is hotter. The hand is warmer or hotter, so therefore the heat will go from in this direction, from the hand to the ice. All right, so what it means is that the hand will lose heat and the ice will gain heat. Okay, so let's write it again. So I have the hand and I have the ice. The hand is hotter than the ice. So the ice is cooler. All right, the ice is cooler. So therefore, heat is going to travel in this direction from the hand to the ice, and therefore the hand will decrease in temperature because there's losing heat, and the ice will gain heat, so it increases in temperature. So after heat is transferred, the temperature of the hotter object becomes what happens, and the temperature of the cooler object what happens. Okay, so the temperature of the hotter object will decrease and the temperature of the cooler object will increase. All right, so let's look back at the hand and the ice. So let's look at over on top over here. So we have the hand and the ice. So after heat is transferred, so the hand has transferred the heat to the ice. After, what happens? So the hand will become cooler and the ice will become warmer. All right, so the temperature will increase for the ice and decrease for the hand. How is heat transferred? It's transferred from the hotter to the cooler. So always remember, from the hotter to the cooler is never ever from the cooler to the hotter. All right, so if you have a warmer object here, if a cooler object, heat is always transferred in this way, and it is not in this way. A lot of questions will ask you which direction the heat is going to transfer, so it's always this way. So let's look at some examples over here. You have seen some of these. Hand and ice, which one will be transferred to which one? So its hand is warmer than ice, so it's hand to the ice. The heat is transferred from the hand to the ice. Hot coffee and spoon. In what direction will the heat be transferred? Is from the hot coffee to the spoon. A hot student who's feeling warm in an aircon room. Which is warmer? The hot student is warmer, so it's hot student to the aircon. The heat goes from the hot student to the aircon. Water and ice, which is warmer? So water is warmer than ice, so therefore heat is transferred from water to ice. Okay, let's try this one, which is cold water to freezer. Which is warmer? Is cold water warmer or is freezer warmer? So cold water is warmer, so therefore the heat is from the cold water to the freezer, and then after that the water will eventually freeze as well. So heat will continue to transfer. Heat will continue to transfer until when? They will transfer until the temperature of the objects are the same. All right, so what does that mean? is that the hand will transfer heat to the ice until the temperature is the same. The hot coffee will transfer heat to the spoon until the temperature becomes the same. Alright, which means they are both like quite hot. The hot student will transfer heat to the aircon room until the temperature becomes the same. So if the aircon is like 18 degrees Celsius and the hot student is wearing a singlet or the shirt that has a lot of perspiration on it, then he or she will feel cold very soon. Alright, so water will transfer heat to ice again until the temperature becomes the same. Cold water will transfer heat to the freezer until the temperature becomes the same as the freezer, which is usually below 0 degrees, and that's why the cold water will eventually become ice. So how does heat transfer when you put a metal spoon into a cup of hot tea? We went through this just now. Heat from the hot tea is transferred to the metal spoon. So this is the hot tea. Alright, it will transfer the heat to the metal spoon, and then the metal spoon will start to feel hot. Now interestingly, this is going to be hot as well. This part of the spoon is going to be hot. Now question, between the metal spoon and the air, how is heat going to be transferred? So which is warmer? Is the metal spoon warmer or the air warmer? So the metal spoon is warmer is because of the hot tea, and therefore the metal spoon will transfer heat to the air around it. Alright, so the metal spoon will transfer heat to the air surrounding the metal spoon because the metal spoon is warmer than the air. So how will heat transfer when you hold a cold can of soft drink? So this is your hand, and this is a cold soft drink. Which is warmer? So I have hand and I have cold drink. Which one is warmer? So this one is warmer, so therefore heat is going to transfer in this direction from the hand to the cold drink. Alright, from the hand to the cold drink. And it will transfer until the temperature becomes the same. Alright. Likewise for the tea, from the tea to the spoon, it will transfer until the tea and the spoon are the same temperature. Okay. Alright, so now we're going to do sources of heat. What is a source of heat? Something that gives out heat on its own. So you have things like the fire, which is, this is a fire. You have things like a sun, which is also a source of heat, like an iron. These are all sources of heat, so they give out heat on its own. Common sources of heat at home: light bulb, toaster, hairdryer, iron, oven. Like these are sources of heat. And also the fire that you use to cook, that's also a source of heat. So fuels, when you burn fuels, they also become sources of heat. Alright, so this is the one that you use to cook at home. You burn gas and you get this. This is the one you burn in a fireplace. Alright, this is a source of heat that you burn in a car. Alright, you burn in a car to make it move. And this is coal. Usually they burn for heat energy, to generate heat or to generate electricity in a coal power plant. So these are some common sources of heat. You have coal, you have gas, you have oil, petrol, wood, charcoal. If you want to go barbecue, you need to have charcoal to burn and cook your food. So these are some of the sources of heat. So what kinds of energy are produced by burning fuels? You have heat and light energy when you burn fuel. Alright, so when you burn charcoal, you have heat energy from charcoal to cook your food. You have light energy that you see from the charcoal because it's red. Over here, this cooking stove as well. Alright, when you burn it, you have heat energy to cook on your stove. You have light energy because you can see the flame. So what is the most important source of heat on Earth? It is actually the sun. Alright, the sun is actually the most important source of two kinds of energy, which is heat energy and light energy. Alright, so this is the main root source of heat and light on Earth. And what are some common uses for the sun's heat? Stay warm and dry clothes. So this is the sun. You use the sun's heat to put your clothes outside, you can dry. Singapore is a really warm place, so you don't really see a situation like that where it's snowy. But if you have been to a cold country, then you know that when you are under the sun, it feels so much more comfortable because there's heat coming from the sun. All right, so it's really important. These are some just common uses of the sun's heat. So let's talk about some good and bad conductors of heat. So basically, what is this word conductor? All right, conductor means it allows heat to go through it. All right, it allows heat to go through it. So let's say I have a source of heat over here, and I have something. All right, this is a material, and if this part feels hot, all right, this is my fire, and if this part feels hot, then this is a good conductor. If this part feels cool, then this is a bad conductor because it doesn't allow the heat to travel through here. All right, so that's basically what conductors mean. So what are some good conductors of heat? You have mostly metals. So I have a picture of a few metals here. You have iron, aluminum, you have copper, steel, bronze, brass, metal sludge. Now, basically, if you are a metal, it's a good conductor of heat. And if you don't believe me, you put a pot of water, all right, and let it boil, and you put a metal spoon inside. You put a metal spoon inside, and then after a while, you use your hands and touch this point, and you see whether it's hot or cold. So it should be quite warm, all right? And if you put a wooden spoon on this side, let's use another color, wooden spoon on this side, and then you touch this point, and it will feel much cooler than this one. So the metal is conducting the heat from the water to this part, and the wood doesn't really conduct much heat from the water to this point. Okay, so that's what it means by good and bad conductor, basically. So good conductors of heat allow, what do they allow? They allow heat to flow through them easily. All right, if we look at the diagram here again, so boiling water, the heat can easily flow upwards for metal spoon, for wooden spoon, it cannot flow upwards this way, so it doesn't allow heat to flow through easily. So what are some poor conductors of heat? What are some over here poor conductors of heat? You have plastics, wood, and air. So air is or to be more specific, it's actually called trapped air. Trapped air is a poor conductor of heat. So you have this is a window, all right, and you have outside glass, you have inside glass. So this is inside of the room, this is inside of the room, and this is outside. So let's say outside is 0 degrees Celsius. It's a cold place. Inside is, let's say, 18 degrees Celsius. So there's a difference of 18 degrees. Heat will travel from which direction? Can you guess? Is it from 0 to 18 or 18 to 0? All right. So heat will travel from 18 to 0, from the warmer to the cooler. Now, what's going to prevent the heat from traveling through is this air gap. Okay, so this air gap is trapped air inside the window, and it will prevent the heat from traveling because it's a bad conductor of heat, or you can say it's a good insulator of heat. So that's how, or a poor conductor of heat. So that's how it can. So when the heat is trying to travel through, what happens is this air gap will try and travel through, and the air gap will sort of like block the heat from traveling through, and therefore it will keep the heat inside. Okay, so this was the experiment I shared with you just now. This is hot water. So with hot water you have wood over here. Let's use another color. You have wood, you have plastic, and you have metal. It's a metal spoon. So which one will feel hot and which one will feel cool? So the metal will feel hot because the heat will be able to transfer upwards. The wood, the heat doesn't really go upwards, so you get stuck here. So the wood and the plastic will not feel warm. All right, it will not feel warm. Okay, so this is a very common question that exams ask. A saucepan should be made of what kind of material? Why? All right, so a saucepan, it should be made from a good conductors like metal, so it can conduct the heat from the flame to the food. Okay, so let's look at this saucepan, and if I have some fire over here, my food is inside. So let's say I have a drumstick. All right, this is a drumstick. So I want to cook my drumstick in this saucepan, and if I have a good conductor here, then I can conduct the heat from the flame to the food. But if I have a bad conductor, and then the heat will not be able to touch the food, and that's not good, right? Then my food will not be cooked. So metals such as metals are good conductors of heat. So copper, gold, aluminium, and we use not gold. The gold is a bit too expensive, so usually we use like metal, like iron or aluminium to make our saucepans. All right. But the handle of a saucepan should be made of what? So it should be made of poor conductors so that our hands will not be scalded. Scalded means you touch it and then it's very painful. It will like burn your hand because it's painful. So this is the kettle, and this is made of the wood. All right, so this is wood, and when you hold the kettle, you will feel warm and not hot. Okay, and this is really quite true. My mum has a wok. Okay, so this is a wok, and this wok is quite interesting. It's very expensive, but the whole thing is made of metal. Even the handles are made of metal. Okay, and when she cooks, or when she steams a fish, or when she fries vegetable or something, right? And she wants to hold the wok to pour out the food, she has to use a cloth to hold the sides of the wok. Otherwise, her hand will be burnt. So I think it's not a very good design. I don't know why they did it this way. So after I looked at it, maybe because metal is more lasting than wood or plastic. Alright, that's why they use metal. This whole thing is made of metal, which is really hot. So what I'm trying to say is that metals can really conduct heat. When you are frying something, your wok is frying something, or you are boiling something, you touch it, it's going to be painful. I got burned a few times before. So metals really conduct heat. Alright, so not a very good wok. So why are blankets, clothes, and oven gloves poor conductors of heat? Why are they? Because they have pockets of air trapped inside the fabric, and they trap a layer of air close to the body. So let's take a closer look at this. Okay, so this is your skin surface. Alright, this is your skin surface, and this wool or blankets or whatever, they have all these little pockets of air that is trapped in between the fibers of the wool, and okay, so this is cool air outside, and this is your warm body here. So where will heat travel? Is it from the cool air to the warm body, or the warm body to the cool air? So it's warm body to the cool air. But the thing is, as the heat is trying to travel up, it hits the pockets of air. Alright, all these pockets of air. It's trying to go out, and it hits all these little pockets of air. And these pockets of air are poor conductors, so they don't allow the heat to go all the way to the cool air. And that's how you trap the heat in your body, and you prevent the heat from reaching out into the cool air. So that's how these blankets, sweaters, and jackets, how they work. Alright, so they all have a trapped pockets of air in between their fibers like this. So how does a cooler keep food hot and drinks cold? So cooler is something like, this is a cooler. What happens is there's a cover, you actually put like canned drinks inside here. You put canned drinks over here, or you put like ice inside here to keep things cold. So how does it keep things cold? What is the thing? So over here, this is actually you cut the cooler in half. So I don't know whether you can see it. This is one half, this is the other half. So in between, you have all this spongy material. All right, you have this spongy material, and inside this material, you're going to have a lot of air pockets as well. Okay, so these air pockets will prevent the heat from going in, or will prevent the heat from going out. Now, question: if I have a can of cold drinks, a lot of cold drinks with ice, where is the heat going to travel? All right, so this is normal air outside. This is ice and water and cold drinks. So the heat is going to travel in this way from the warm air to the cold drinks. And again, all these pockets of air will prevent the heat from going in. Now, if I have hot chicken or hot food, you know, I put some hot food inside here. So I have some hot food. I have some hot food here, and I have normal air outside. Let's put my air outside here. How is my heat going to travel? Is it from the air to my hot food or hot food to the air? So it's actually from the hot food to the air. But again, all my pockets of air will prevent it from reaching the air, and it will stop the heat transfer over here. And that's why I can keep my my food hot or my cold drinks cold. How do animals like huskies and polar bears keep warm? Alright, so they live in a very cold place, like maybe like North Pole, which is, I don't know, minus 25 degrees Celsius. It's very, very cold, huh? So their fur traps a layer of air close to their bodies, and air is a poor conductor of heat, or to be more specific, trapped air is a poor conductor of heat. So again, the polar bear has a thick fur coat, so in between, so this is draw it bigger, so this is the hair of the polar bear, this is the body of the polar bear, and this is cold air. So where is heat going to go? From here to here or here to here? Cold air to body or body to cold air? It's from body to cold air. And all this fur will trap a lot of pockets of air. So when the heat is trying to go out from the body to the cold air, it will be stopped by all the pockets of air, and that's how it prevents, that's how the polar bear keeps warm in such cold temperatures. So next we're going to look at what is temperature. Alright, so what is temperature? Temperature is a measure of how hot something is. It's like for mass you have kg, for length you have cm, so for temperature you have something called degrees Celsius, which is how hot something is. That's quite interesting, you know, when, so long time ago, a few hundred years ago, when they were trying to decide how to measure temperature, so this guy was quite smart, so he said, all right, let's, this is a mountain, this is a mountain, and this is the sea. So he said, okay, let's go to the sea, at the sea level, take some pure water, all right, so this is a story of how degrees Celsius came about. So take some pure water, at the temperature that the water becomes ice at the sea level, all right, we will call it 0 degrees Celsius. That's quite smart, huh? So 0 at the temperature that it boils at sea level. All right, so at the temperature that it boils at sea level, we will call it 100 degrees Celsius. Right? So there's no I don't know. There's no like, it's not like, you know, it was like that since mankind started. So this guy called Celsius lah, he just said, let's just say ice is 0, boiling is 100 degrees Celsius, and in between we will split it into 100 segments, and that's how the Celsius scale came about. All right, so that's quite interesting, right? Which is ice is 0, boiling is 100. We'll just break it up into 100, and that's how the Celsius scale came about, which I thought was quite interesting. So what do you use to measure temperature? All right, it's a thermometer. So this is how a thermometer looks like. There are some markings over here. So there are two common scales. So one of them is degrees Celsius, the other one is degrees Fahrenheit. Singapore and most of the world will use degrees Celsius. Only USA and I think one other country uses degrees Fahrenheit, which is a bit different from what we do. So so again, this is where ice will freeze, and 50, so all the way to 100 is where water will boil. And in between, they split it up into 100 segments, and that's just how it works. All right. So you just take when ice freeze, you mark it at 0. Take 100, you mark it at boiling. Put some kind of liquid here that will expand when it is hot and contract when it is cool. Then divide it into 100, and that's a thermometer. Alright, so how do you actually use a thermometer? Place the bulb, so this is the bulb, alright, into the substance you wish to measure. So if you want to measure water, you place it into the water. If you want to measure, so let's say this person is sick. Oh, I'm feeling sick. Alright, I have a fever. So where should you place the bulb? Usually you place it in the mouth, alright, or under the armpit. That's where you measure the temperature of the person and you can see whether the person is running a fever. Alright, so place the bulb into the substance you wish to measure, and then the alcohol or mercury will move up or down. Wait until what happened? It stops moving. So it will go up and down. So let's say you place it inside, and then from here it increases to here. So wait until it stops increasing. Then what happens? So read the level on the thermometer by placing your eyes at the same level as the thermometer. So you're going to place your eyes at this level, alright? Same level as the thermometer. If you're going to place your eyes on top of the thermometer like this, or from the bottom like this, then you're going to see different kinds of readings, okay? So it's important to place it at the same level as the mercury or the alcohol of the thermometer. Okay, so this is interesting. Mercury is actually poisonous. Alright, if you break a mercury thermometer, do not touch it. So mercury will look like this, which is silvery in, it's a silver color. Do you know why it's silver color and why it's good for making thermometers? Alright, because mercury is actually a metal. Alright, I don't know whether you knew that, but mercury is a metal that is liquid at room temperature. Okay, so what that means is the temperature that you and I are alive in, mercury is actually a liquid. If you look at any other metal like copper, bronze, metal, iron, steel, they're all solids. Okay, so mercury is actually the only metal that's a liquid at a temperature. And remember, what is metal? Metal is a good conductor of heat. So that's why when you put the mercury thermometer into a substance, it will quickly conduct the heat from the substance to the mercury, and then it will detect the heat very well. So that's a great material to make a thermometer with. The only thing is it's actually super poisonous. Okay, so mercury, you touch it, you eat it, it's very bad for you. So I'll show you how bad over here. So this is, I don't know how to spell, acrodynia, alright? It's actually the mercury poisoning. You can see all your skin and your feet turning into like pink. Pink is very bad. You have this Minamata disease as well. It like makes you makes you become stupid or retarded. Okay, so it's really poisonous. So that's why they sort of like stop having mercury thermometers, especially for if you're going to do mouth thermometers. Okay, so last time what happened was people will put it in and the kid doesn't know, the kid will bite the thermometer and then all the glass and mercury in the mouth, then they'll swallow it, and that's really not good. Alright, so after a while it starts to affect your brain, don't become so smart anymore. So mercury, great conductor, detects heat very well because it's a liquid metal, but very poisonous. Okay, so the poison part don't have to learn. This is just for your information. Because I see the textbooks, they keep saying it's poisonous, but they never actually show you how poisonous it is. So I thought it's quite interesting to show you that this is what happens when you eat mercury. Right, very bad, huh? So let's look at temperature units. In Singapore, again, we do degrees Celsius. It's written like this, degree Celsius. All right, degree Celsius. So you have 20 degrees Celsius. Usual temperature in Singapore between 28 to 33 degrees Celsius. All right, that's the usual temperature. When it gets very, I think coldest ever in Singapore is 21 degrees Celsius. Hottest ever, maybe 36 degrees Celsius. Okay, boiling water, again, 100 degrees Celsius. Dubai, all right, a very hot country in the middle of the Middle East. I heard during the days it can go up to 48 degrees Celsius, which is crazy. You will like die if you are walking across. Okay, so I went to Taiwan once and it was 38 degrees Celsius. I walked across a road. So I walked across this road, a small road, just 2 lanes. So I just walked across under the sun, and by the time I reached this side, I almost fainted really. Okay, so it's really hot, and you have to drink a lot of water. Just take care of yourself. Yeah, heat is not funny. Okay, so now we're going to look at a very confusing part of heat, which is called changing states. Alright, so there's a lot of things. Gas lose heat, it becomes this, blah, 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 blah. Gain heat, lose heat, gain heat, lose heat. So it's actually quite a confusing part because there's a lot of things to memorize. But I came up with this triangle, which I think it will really help students to remember what's going on. So the first thing is this triangle, you put solid, liquid, and gas. Okay, so you can think of solid, liquid, gas, which I find easier to remember, or you can think of gas, liquid, solid. All right, so GLS or solid, liquid, gas from the top. Now this arrow is going up, this arrow is coming down. So this arrow is going up means it will gain heat, and this arrow is coming down means it will lose heat. Okay, so solid, liquid, gas, gain heat, lose heat. So solid to liquid going up, it will gain heat. Liquid to gas, it will gain heat before it becomes liquid to gas. Gas to liquid, lose heat. Liquid to solid, lose heat. So then you need to remember the processes, which is all these lines in between. So solid to liquid is melting. Liquid to gas is actually boiling. Okay, so just think of water. Solid ice to liquid, which is water, is melting. Liquid to gas is boiling. Gas to liquid is condensation. And liquid to solid is freezing. Okay, so freezing is a losing heat. Condensation is losing heat because the arrow is going down. Melting, boiling is gaining heat because the arrow is going up. And to even simplify it more, use this as ice. Solid is ice. Use water to represent it. Liquid is water, and gas is vapor. Okay, so from ice to water is melting, water to vapor is boiling, vapor to water is condensation, water to ice is freezing. So if you remember this, then it will be much easier for you to remember all this part. Right, now that we have gone through the triangle of change, all right, where you have your solid, liquid, and your gas, we're going to look at water and the 3 states of water. Now basically water has got 3 states as well. There is a solid state, a liquid state, and a gaseous state. You need to know the names for all 3. So the solid state of water is ice, all right? And the liquid state of water is water. And the gaseous state of water is water vapor. All right, please don't write short forms in your notes. Write down the entire words water vapor. I write WV to make the lesson faster, make the video faster. Okay, now these 3 words should not be new to you. All right, if they are, you have bigger problems in science than just answering section B questions. Okay, so ice is something that's cold. You put in your drink, makes it delicious. All right, nice, cold on a hot day. Water is what you drink every day at home. Water vapor is what happens when you see condensation and stuff like that. All right, so ice cube changing from solid ice to liquid is called changing states. Okay, solid to liquid is called melting. Right, not changing states, but rather melting. What happens when you add heat to water? So you have solid, liquid, gas. You have heat going up, heat coming down. Liquid to gas, heat, water. This part, what happens to it? It's called water change state to become a gas, and the process is called boiling. All right. What happens when you heat an ice cube? So you have an ice cube over here, and you heat it up. So from here it goes to liquid, it melts. All right, so that's the process. When water gains heat from a fire, the temperature, water gains heat from the fire from liquid to gas. Over here, the temperature will increase over here, And when water loses heat in a fridge, the temperature will decrease. So when water loses a lot of heat in a freezer to become ice, which part of the triangle is it in? It's over here, from liquid to solid. So this is called freezing. Okay? And this is called condensation. Condensation. So that's the triangle. Very useful to help you write down, try to think of like what are the right words, or what is the process, what's the name of the process. Can get a bit tricky at times, I understand. So that's where it comes to help you. Now we're going to look at expansion and contraction. Okay, so basically what happens is when you heat something up, when you heat a object or a matter, it will expand. All right, it will expand and it will take up more space. All right, that's what expansion basically means, or the volume will increase. That's what expansion means. It will take up more space, the volume will increase. When you cool something down, it will contract. Now what happens when it contracts? It takes up less space. Okay, the volume will decrease. The volume decreases, it takes up less space. So that's basically what expansion means. Take up more space, more volume, volume increases. Cool, contract, takes up less space, volume decreases. Now let's look at the first question over here. What will happen if rods do not have expansion joints? So what are expansion joints? So these are expansion joints in the rod. All right, so you see in the rod, in the middle of the rod you have this. So what happens is when the rod expands, all right, when the rod expands under the heat, it takes up more space. And if you see this space over here, wait, let me just draw this out. This space over here, all these gaps, these are all the spaces. So all these spaces will, it will basically like this, right? And then it will go in and touch each other. When it's hot, when it's cool, it will contract and it will come out like that. Okay, hot, expand and cover up the space. Cool, it will contract and you can see the spaces over here. Okay, so this day, I can suspect, is a rather cool day, all right, because you can see the spaces and the gaps over here. Now, if it's a hot day, then the space will be smaller. You'll see a smaller space over here. Okay, and what will happen if you do not have all these expansion joints? Now, you're going to see things like this. You're going to see cracks on the rod, all right? The rods will crack when it expands under the hot sun. So that's what's going to happen. The rods will crack because there's no space for the rod to expand. So this is, let's say this is the rod. Okay, look at my fingers. This is the rod. No space to expand. It will expand out, and then after that, crack. All right, it will like crack. Okay, so that's what happens to the rods when there is no expansion joints. All right, let's look at this one. What will happen if train tracks do not have expansion joints? Now this is the expansion joint of a train track. This one, this 4 nuts over here, right? Can you see this hole over here? This is where you the train tracks will be able to expand and contract. Now, because solids will not expand and contract a lot because they have a definite volume after all. So their expansion and contraction is very little. So this small space over here is already enough for the train tracks to expand and contract. Now this is another image over here you can see. So you can see that this is the nut holding the two parts of the train tracks together, and this is a joint for it to expand. Okay, and what's going to happen if train tracks do not have the expansion joints? And then the train tracks will bend when they expand under the hot sun. So it will look, the train track supposed to be straight, right? So if it doesn't, then it will like that. It will be bent, okay, under the hot sun. So that's what will happen to the train tracks. Okay, when matter is heated, what happens to the volume? The volume of the matter increases. Likewise, when matter is cooled, what happens to the volume? The volume decreases. All right, it'll take up less space. Now, what will happen to alcohol when cooled? This is actually a question for like thermometer lah. If I use a alcohol thermometer, what will happen to it when it's cooled? It will contract, reduce, the volume will reduce, and then therefore the reading will go down. Okay, so it's, let's say for example it's actually here. Okay, this is alcohol, And this is my reading. So now it's a bit cooler. It's a bit cooler now. So what's going to happen? So it's cooler now. It will go down and down because it will take up less space. And now it's a bit warmer. What do you think is going to happen? The thing will increase in volume and take up more space, and it will go up and up. Okay, so that's basically how a thermometer works. It works on the principle that warming things up will cause the volume to increase, and cooling it will cause the volume to decrease, and that's why the thermometer can go up and down. Okay, so when you heat matter, the volume increases. What is this process called? It's called expansion. Alright, so I've got a little joke here. Heat makes things expand, so I don't have a weight problem. I'm just hot. Okay, so because when you're hot, you will expand, and therefore you don't have a weight problem. You're just hot. Ha ha ha. Quite funny, right? I thought it's quite funny. Okay, let's go on. How can you help to conserve energy? So these are some simple ways. Use fan instead of aircon, walk instead of drive, turn off electrical appliance when not in use. Some of my students are very particular about this, so every time I leave the appliance on, they'll tell me to switch it off. So that's a good thing, and that's how you can save electricity.